Welcome to Study Loop.
41.14. Under some assumptions that we're going to make, we want to figure out what percentage of the volume in two different metals is occupied by conduction electrons. And we just assume that the volume of a sample of metal is equal to the sum of the volume of the metal ions plus the volume occupied by the conduction electrons. So we want to do this for sodium and for copper, and then think about which one of these is going to be more like a free electron gas. So for sodium, its density is 971 kilograms per meter cubed. So sodium will actually float on water. It also combusts on exposure to water, but it's because sodium doesn't like existing by itself. Anyway, its molar mass, we're told, is 23 grams per mole. Now you're just going to assume that the radius of the sodium ion is 98 picometers. So the volume occupied by the sodium ions out of the total volume, so we're going to have the density of the sodium ions, because the electrons are not going to contribute to the mass really. Have the Avogadro constant here, 4/3 pi, and then our radius cubed. And this is divided by the molar mass. So this equals 0.1 or 10%. Oh, right, yeah. So then the volume of the electrons is going to be 100% minus the percent the sodium ions make up, which is 90%. So now we rinse and repeat for copper. We're told that the density of copper is 8,960 kilograms per cubic meter. Copper will not float on water in my experience. 63.5 grams per mole. I mean, unless it's some sort of hollow thing like you get with boats, but that doesn't really count as being just a bulk sample of copper, because then it's mostly air inside. And radius of the ions of 135 picometers. And so and a unit volume of copper, let's write this out symbolically, I think, this time. We have the density times Avogadro's number times the volume per ion so this is the sort of number of ions per unit volume, and then that's the volume of one ion. And so we end up with, this is 18, no, sorry, this is 87.6%. And so then this implies that the volume occupied by electrons is 12.4%. And so it's pretty straightforward to say that sodium, where it's 90% of the volume is conduction electrons, behaves more like a free electron gas because 90% of the space is occupied by the electrons and not, 12%.